Dear students, this is the second class on the chapter Calculus Recapitulation, and in this class we are going to learn continuity of a function. That is how to test whether a given function is has continuity or continuous or not continuous. So let us start. First, we need to know what is continuity. So if you have given a function fx and if it is plotted on a graph and the graph has no breaks on it, that is it is continuous everywhere, then the function is said to be continuous everywhere. So, for example, here is a graph shown, the graph of the equation y is equal to x squared. That is, in this case, y is a function of x. And see here from this figure that this graph has no breaks at anywhere. That means it is completely continuous. So, the function y is equal to then said to be continuous. So, from here we can just say that if you plot a given function and that function, if the function has no breaks on it, then it is said to be a continuous function. And in mathematics or in the mathematical definition of continuity, it is said that the function fx is said to be continuous if its left hand limit and the right hand limit both exist and are finite and are equal. That is, limit x tends to a minus fx is equal to x tends to a plus fx, that is equal to fa. That is, in this case, the definition has given for the point x is equal to a. So this is the mathematical definition. Hence, if fx is continuous at x equal to a, then fx must exist. The function must have finite value, and obviously the left hand limit and the right hand limit both are equal, and they have the same value, identical value as that of fa. So now come to the continuity of a function in an interval. If fx is a function such that it is continuous at every point in a interval, in an open interval av, then it is said to be continuous in the interval av. So if that means if fx is a function, you have given a function fx and its open interval is given as av, then you have to test whether fx has finite left hand limit and right hand limit. And if both are finite and are equal, then you can easily come to a conclusion that the function is continuous in the open interval ab. However, if the function fx is defined in the closed interval, here it is the closed interval av, then the function is also said to be have continuity if it is continuous in the open interval ab. So if you have given an even a closed interval, then just you check whether the function is continuous or not in the open interval. If it does, then you can conclude that the given function is continuous in that interval. Okay, the function is now another one is here. The function is continuous from the right at a and continuous from the left at b. That is left and right. That is this is the right hand limit, that is the limit x tends to a plus if x is finite, and if b, another one is x limit x tends to b minus if x is finite. That means the left hand that I already told it that already said it that both the left hand limit and the right hand limit are to be equal. So are to be finite. Okay, now important properties of continuous functions. Here are some important properties. Number one is if fx and gx are continuous at x equal to a, at the point you have given two functions fx and gx, and if those functions are continuous at a given point x equal to a, then fx plus minus gx can also be continuous at x equal to a. So the condition is here. The condition is that fx and gx, if fx and gx are continuous at x equal to a, then their sum and subtraction both are also be continuous at that point, that is x equal to a. Now another one is the next one is fx and gx, that is the multiplication of these two functions is also continuous at x equal to a. And finally this is another one, fx by gx. This is also to be continuous at x equal to a, but remember that the condition is that gn not is equal to function of a is not is equal to 0. And in this and the final one is that should be noted that if fx is continuous at x equal to a, that you have given two functions fx and gx, and if any one of them is continuous and another is not, that means if fx is continuous but gx is not, or vice versa, in that case fx plus minus gx is continuous, but their multiplication, that means fx gx may or may not continuous. So that should be that should depends on the testing of the continuity of that function. So in that case the multiplication is may be continuous or may not be continuous. And here is another point, every polynomial function is continuous everywhere. If you have given a polynomial function, then it is continuous everywhere. And in the similar way, or in addition to this, a rational number is also continuous every point at every point, but the condition in that case is that the denominator should not be 0. So this is the condition. If for a rational number the denominator is not 0, then the function is continuous. So now come to the discontinuity. So what is discontinuity? We already know, we already learned that the condition of a function to be continuous, that is the left hand limit and right hand limit are should exist equal and have finite values, and those finite values are equal to on the value of that function at the point x is equal to a. If however any one of these functions, that is if however the left hand limit or the right hand limit, either of the left hand limit and right hand limit or both of them are not continuous, then the function at the point a is said to have discontinuity. So that is here, a function which is not continuous at a point is said to have discontinuity at the point. If fx is not continuous at the point a, then the function will have discontinuity at x equal to. That means the left hand limit and right hand limit should not equal, and not may not be finite, or may not equal to a function of if a, that is the value of the function at a. And there are several kinds of discontinuity. I have summarized them here. First one is discontinuity of first kind. Though this is the first kind of discontinuity, and it is named as it is, and it is called as discontinuity of first kind. So what is that? If both the left hand limit and right hand limit exist but are not equal at the point x is equal to a. So you have given a function fx, you have calculated the value of x, the left hand limit, and also you have calculated the right hand limit, and if they are not equal to each other, then the discontinuity will said to be of first kind. And the second discontinuity of second kind, if either or both left hand limit and right hand limit does not exist. So if if any one of them, that is this left hand limit or this the right hand limit or both of them does not exist, that is they have not finite value, that is finite value that are there for a given point x is equal to a, or they have infinite value, then this type of continuity is called the discontinuity of second kind. And next one is mixed continuity. If the given function f is said to have mixed discontinuity at x equal to a, if one of the limits, that is the left hand limit or the right hand limit exists, and anyone exists but other does not exist. So you have given two functions. One is you have given a function fx. You have tested, that checked that whether it is continuous or not. That for that you have to find out the value of left hand limit, that is this, and the right hand limit, that is this. And if any one of them, that is this one or this one, exists but the rest one does not exist, that is if it is exist it does not, or vice versa, then it is said to, then the function fx is said to have mixed discontinuity. Jumped discontinuity in the next one is if both the limits, that is the left hand limit that is here and the right hand limit that is here, exist but are not equal. Both of them exist but are not equal, they have different values, then the function fx is said to have jumped discontinuity at x equal to a. So and the difference of them actually give the jumping of the jump of the function. So if you calculate the value of left hand limit and that is right hand limit and the left hand limit, and you observe that these two limits are not equal, so from that point you can say that this function has jumped discontinuity and at the point x equal to a. And however in this case fa may not equal to either of the limits, so in this you can also find out the value of fa, and in that case, in this case, this left hand limit and this right hand limit may not equal to fa. And to find out the jump of the limit, you have to calculate the difference of these left hand and right hand limits, that is the left hand limit, the difference of the left hand limit and the right hand limit is called the jump of the function. And a function having finite number of jumps in a given interval, so if you have given this function fx and it has a finite number of jumps in a given interval, say ab, in the interval ab the function fx has finite number of jumps, then the function may be said to have piecewise continuous function, so said to have piecewise continuity. So interesting thing is here, that is you have given a function and you observe or you see that this function have finite number of jumps, there are several jumps in a given interval, and in this sense, in that case, you can say that this function is piecewise continuous. And another one is oscillating discontinuity. If you have given a function fx and that fx is you have given a function fx and that fx oscillates finitely or infinitely, that is the function is for different values of x, it is oscillating finitely, or maybe the oscillation may be infinitely as x tends to a, either from the left or from the right, both of the limits, then fx is said to have oscillating discontinuity at x equal to a. So this is the definition of oscillating discontinuity, and we learn different kind of discontinuity in this section. And now we have to check test whether a given function is continuous or not. And here are some examples. Number one is examine the continuity of the function fx is equal to x square minus 16 by x minus 4 when x is not is equal to 4. That means x tends to x may be higher than 4 or may be less than 4. That is x tends to 4. X is from the first case x is less than 4 but may be close to 4, or x is greater than 4 but close to 4. So the limit may be treated as x tends to 4. Okay, so the given function is there. If x is equal to x square minus 16 by x minus 4, and from the given function we can calculate the left hand limit, and we know the left hand limit can be written in this way, that left hand limit is written in this way, that is left limit x tends to 4 minus fx, and that is equal to limit x tends to 4 minus x square minus 16 by x minus 4. And now just let or put or substitute x is equal to 4 minus a, and when x tends to 4 then h tends to 0, and from you know that, and you can write this limit in, that is limit x tends to 4 minus fx in this fashion, that is limit h tends to 0. In that case this x should be replaced by 4 minus x, that is done here. Okay, that is equal to limit h tends to 0, 4 plus 4 minus h whole square minus 4 square by 4 minus h. Let's simplify this, and after simplifying function, finally you get h tends to 0, 8 minus h into minus h by h, that is limit h tends to 0, 8 minus h. And using the value of h, you can find out that the left hand limit of the given function at the point x is equal to 4 is 8. Now to find out the right hand limit, so in the similar way you can find out the right hand limit, that is the right hand limit is given here, limit x tends to 4 plus fx, and in this case you have to replace x by 4 plus h, 4 plus h. So that is here limit x tends to 4 plus x square minus 16 by, this can be written in this way. So that is here, and in the substitution is here also written here. So in here, so this right hand limit can be written here as limit h tends to 0 x, here x should be replaced by x plus 4, h plus 4, that is here h plus 4 whole square minus 4 square by h plus 4 then minus 4. So after simplification you also obtain in this case that the right hand limit is equal to 8. So here we observe that the left hand limit and the right hand limit at the point x is equal to 4 are equal. So here, since they are equal, so we can conclude that the given function is continuous at the point x is equal to 4. The next one is here, the next example, next problem is here, discuss the continuity of fx is equal to e to the power x minus 1 by e to the power x plus 1, x not is equal to 0. So in this case we can use the use x tends to 0. So that is here. So the given function is also written as this, and the left hand limit can be calculated as limit x tends to 0 minus fx, that is equal to x tends to 0 minus, the value is just written here, and in this case you can write or substitute x tends to 0 minus h. So this limit then can be transferred to this, that is h tends to 0 e to the power 1 by h minus 0, and then minus 1 by e to the power 1 by h minus 0, then this is a plus 1, and just this is a simplification, and you have obtained fx is equal to minus 1. And now you have to calculate the value of right hand limit. The right hand limit is here calculated here, limit x tends to 0 plus fx, that is equal to limit x tends to 0 plus e to the power 1 by x, that is written the function, the value of the function is written here, and in this case the substitution should be x is equal to 0 plus h. So this limit then transferred to h tends to 0, these all values are h, all x are replaced by h plus 0. And also you calculate this, you see here that you obtain finally limit h tends to 0 e to the power 1 by h minus 1 e to the power 1 by h plus 1. So 1 by h, that is 1 by 0, that is infinity. So this term is infinity by infinity in this form. So this is not, this is and in this way you cannot calculate the value of the limit of the value of this. So only you can to find out the value of left and right hand limit, you have to just take this form, take this term from here, this is the term, and multiply and multiply, or multiply this term with, that is numerator dividing, multiply e to by e to the minus 1 by h, or divide by e to the power 1 by h of the numerator and denominator. That will provide you limit h tends to 0 e to the 1 minus e to the minus 1 by h, then 1 plus e to the minus 1 by h. So after that you can find out the value of right hand limit as 1. So here you can easily understand, and you can easily find that the value of left hand limit is not equal to the value of the right hand limit. So the given function is not continuous at x equal to 0. The next example is here, show that if x is equal to mod x by x is not continuous at x is equal to 0. So this is the given function mod x by x, and the left hand limit is here, limit x tends to 0 minus fx, that is equal to limit x tends to 0 minus mod x by x. And you know that for in this case we can substitute x by 0 minus x, and we have, and it has been carried out here, it has been done here, that is limit x tends to 0 minus fx, that can be written as limit h tends to 0, then this x should be replaced by 0 minus h mod by 0 into h, sorry, 0 minus h, that should give you mod minus h by h, that is equal to this, that is minus 1. And the right hand limit is also calculated here, and that in that case the right hand limit is equal to obtained as +1. So the left hand limit and the right hand limit are unequal. So in this sense, the given function is not continuous at x is equal to 0. Now come to another one. Discuss the continuity of f(x) is equal to x minus mod x for all x belongs to R, all values of x. So so here is you know that the given function is f(x) is equal to x minus mod x, and you know that from the property of modulus that this mod x would be plus x when x is greater than 0, and this mod x will be minus x when x is less than 0. That is here mod x to x. This is here written here. And now the left hand limit of the given function is limit x tends to 0 minus fx, that is equal to limit x tends to 0 minus and then x plus x, because in this case x is greater than is equal, in this case x is less than 0, that means this x is equal to minus x, and this function will be 2 in 2x, and in that case if you use the value of x, it will give you 0 value, the value 0. And on the similar way, the right hand limit is here. In this case mod x is plus x, so x minus x, that is equal to 0. So you see here, you look these two values, that is the left hand limit and this is the right hand limit, both are equal, and since both are equal, now we have to find out the value of f0, and the value of f0, that is fx at x equal to 0, is also calculated, that is also 0. So in this case you have seen that both left hand limit, right hand limit are equal, and they are also equal to the value of the function at x equal to 0. So the given function is continuous at x equal to 0. Now another one is here, another problem is here. If fx is equal to 5 plus x square when x less than 1, and that is also equal to x minus 4 when x is greater than is equal to 1, you have to check whether the function is continuous at x equal to 1 or not. So the given function is there. I have written also once again this. So now the left hand limit, that is x tends to 1 minus. In this case, x is actually less than 1. So you have to use the value, this value, that is fx equal to 5 plus x square. That is here. And this limit can be written in terms of h, that is x is substituted in this case 1 minus h. So here this limit can be written as h tends to 0, 5, then plus this x should be replaced by 1 minus x whole square, that is equal to 5 plus, and just use the value of h, that is here, so it is equal to 5. So left hand limit is equal to 5, and the right hand limit, now to calculate the right hand limit, so it is here limit x tends to 1 plus, and you know when in this case x is greater than 1, so you have to use this value, that is x equal to fx is equal to x minus 4. That is also also done here. So and also in this case x is equal to 1 plus, the substitution should be this, and then this limit should be transferred to this. So after calculation you get the right hand limit is equal to minus 3. So in this case left hand limit and right hand limit are equal, so there is no question of continuity of this given function. Another example is here. It is you have given a function fx is equal to log 1 plus ax minus log 1 minus bx. So is not defined at x equal to 0. Find the values of f0 so that fx is continuous at x equal to 0. So here you have given that the function fx is continuous at x equal to 0. So if it is continuous, then the left hand limit, that is this, should be equal to the left hand limit should be equal to the right hand limit. So now the right hand limit, first we are calculate, and since it is already stated that the function is continuous, so left hand limit and right hand limit both are equal, and also you know that if a function is if a given function is continuous, then left hand limit and right hand limit is equal to the value of the function at x equal to 0. So in this case, if we only calculate any of the left hand limit or right hand limit, it is sufficient. So here we have calculated the value of the right hand limit, that is limit x tends to 0 plus, that is equal to fx, that is equal to h tends, and that can be written as h tends to 0 f of 0 plus h. In this case x is replaced by 0 plus h, so no problem with this, we know this technique. So thus limit x tends to 0 plus, that is equal to this, and that is equal to here limit h tends to h plus, and here it is missing, limit h tends to 0, then log e 1 plus ah plus log e 1 minus bh by h. That can be written in two parts, that can be divided into separated into two parts, that is first part is this, second part is this. Now from this just you multiply this the denominator and the numerator and the denominator by a, that is here a and here a also. Here also just multiply the numerator and the denominator by minus b. So minus b here, minus b here. So after that just you find out, actually just you have obtained a limit h tends to 0, this and then this minus plus sign, b limit h tends to 0 log this minus bh. So now just replace this ah by y and this minus bh by z and substitute these in this expression you have. And obviously if you replace substitute these, in that case also y should tends to 0 and z should also tends to 0. So this from this line, from this expression you can find limit h tends to 0 plus fx, that is equal to a this, then y tends to 0 log 1 plus y by y, then plus b limit z tends to 0 log 1 plus z by z. That is equal to a into 1 and from here b into 1, because you know that log 1 plus x by x is equal to 1. So from here you obtain right hand limit is equal to a plus b. So since it is continuous, so this is also the value of f0. So f0 is equal to a plus this. Now another problem is here. Find the value of a, b, c so that the function fx is equal to this less than sine a plus 1 x plus sine x by x, in this case x is less than 0, and that is equal to c for x equal to 0, and that is equal to x plus bx square, then minus root x by b to the power x to the power 3 by 2 for x greater than 0. So if the function is continuous, then we know that left hand limit is equal to right hand limit. So now the left hand limit is calculated here, and the left hand limit also can be written as this is equal to h tends to 0 f 0 minus h, and you know that in the case of in this case for the left hand limit the value of x is less than 0, so you have to adopt this value, that is this value. So it has been adopted here, that is left hand limit is equal to h tends to 0, then sine what was there, a plus 1, then x, that means 0 minus h plus sine 0 minus h by 0 minus h. So this is the just simplify it. So from here you can find that h tends to 0 sine a plus 1 h by h, then plus limit h tends to sine h by h. Just multiply both the numerator and the denominator by a plus 1. That is done here in the first term, and the second term is as well as that was previous line. So you know that from here the sine x by x is equal to 1. So this will provide you a value a plus 1, and from here another one. So limit so left hand limit is equal to a plus 2. Now the right hand limit. The right hand limit can also be written in this way, that is h tends to 0 plus h, that is here. So but in this case x is greater than 0, so you have to use the value, this value, that is the value of this root over x plus bx square minus root x by bx to the power 3 by 2. So that is here, but in this case x is replaced by 0 plus h. That is also here 0 plus h, then p into 0 plus h whole square minus this. And after that this is next line is that h plus bx square root over minus h by bh to the 3 by 2, and you can h is taken outside, taken as the common term, that is can be written as this, and this root h, and from here root h will be cancel each other, and from there limit h tends to b plus h to the power half minus 1 by bh. Now multiply the numerator and denominator by the term 1 minus 1 plus bh minus 1. So that is done here. Sorry, multiplied by this term 1 plus bh plus 1. That is done here. And after that you know that from here you obtain 1 plus bh, then minus 1, and bh is there and the rest part is here. So this one will cancel each other, and this bh and this bh also cancel each other. So from here 1 by root 1 plus bh plus 1. So now use the value of just substitute put the value of h, or use the value of h is equal to 0, then you will have this. So right hand limit is equal to half. So from equation 1, that is where is the equation 1, this is the equation 1, that is the left hand limit and right hand limit was equal. So left hand limit, the value of left hand limit was a plus 2 and the right hand limit is half. So this is a plus 2 is equal to half, or from here a is equal to minus 3 by 2. A is equal to minus 3 by 2. So from here we have obtained the value of a. Since the function is continuous at x equal to a, then we also know that left hand limit is equal to right hand limit is equal to the value of the function at x equal to 0. And here in the definition you have seen that the value of f0, that is when x is equal to 0, is c. So from this condition you can write that this c is equal to the value of the left hand limit, that is a plus 2. So from here you calculated c is equal to half. So we actually find out the value of a and c as minus 3 by 2 and half respectively. But however, b can have any values. Here is another problem to find out the continuity in this closed interval. This is the problem, and here it is calculated. Each step of this calculation are being given here. Given here are being written here. Just we have to go through this, and there will be no problem to understand the solution of this problem. And this is another one. Just you need to just calculate yourself, and this and you can compare your calculation with this calculation. So this is the end of this class. So in this class we learn the continuity of function, how to test the continuity of function, and if the function is not continuous at a given point, that it should be a discontinuity, and a different kind of discontinuity. We also learn about different kinds of continuity. So dear students, I suggest you, please go through these all these and calculate yourself, then everything will be clear.